First of all, I'm giving you a problem. First of all, I'm giving you a problem which is of 2 by 2 form. And you tell me what is the maximin and minimax value for this game. Okay. I am continuing this is class 2 of game theory. And those who missed my previous class, they are not going to understand anything if you have not gone through the YouTube video also. So this class is actually the continuation of my previous uh, class, and therefore both the classes are connected to one another. So I'm enabling the chat box so that you can put your responses over there. Okay. And do not write your names right now in the chat box. I can see 23 participants are there. When I ask you to do so, you do so. Okay. Otherwise, your answers will be lost in the in this crowd of answers if you give any answer at all. And one thing, I know that when I have seen often that when a teacher asks question, when a school teacher takes class of children, and I asked not to put any don't. Right now you don't. Arya Modak and Dipendu Halda, don't you understand what I was saying? Right now you don't put any attendance. That would not be counted. I shall instruct and then only you do so. Because I can ask you, I can interact you through chat box. If I ask you any question regarding maths, then you can answer that question only right now. When I shall instruct you to put attendance, then only you put your attendance. Otherwise, this attendance will not be counted. Now, I have often seen that when children are asked about questions, and in online classes, teachers are asking questions, then everybody becomes crazy to give the reply to get praise from the teacher. Okay. Later I shall discuss how much time I will give to for the MCQ. How much time you want? How much time you want, Shumana? Tell me. More than that you are going to get. So so everybody becomes crazy about giving answers and getting praise from the teacher. Everybody wants, all of us wants praise. And what happens with the adult students is that when they are asked questions, they open Google, go to the Stack Exchange, try to find out the question uh, of that sort, and they try to get result from there, and they put the result in the chat box. Okay. And they get praise from the teacher. Now, if you are giving me the answers in that way by putting questions in the Stack Exchange, and we teachers also know about Stack Exchange. So if you do so, that you will be, because since I cannot track you, you will be you will be praised. Maybe you will be praised by the teacher, but actually you have not learned anything. There is a kind of beauty and relaxing kind of thing when people do something by themselves. When I get something from somewhere and I put it, then whether I get praise or not, I'm not actually mentally relaxed, because I know this is not my, don't put attendance, I'm disabling the chat box now. So that is kind of I shall not be relaxing, because I know that is not my originality. I have not solved it, I have copied it from somewhere. Okay. But in this internet era, since I shall not be able to control it, because I cannot control whether you open a Stack Exchange or open any other source. So I actually kept thinking about that, and I have come to feel something about it. That first feeling was that, first feeling from the student's perspective, I'm saying that if a particular student is seeing the answer from the Stack Exchange or from any other source, then also he is learning, because he's trying to get the answer, and it's getting into his memory, with or without his knowledge. And another thing which I have decided not to do is that uh, in this scenario, I shall not praise you if you give me the answer. I want just the answer. If someone gives me the answer, I'll say, okay, so this is the answer. Because I'm not going to praise anyone. So do not think that to have make me happy, you are actually kind of in a kind of competition and you are getting answers from different sources and putting in the chat box. I can ask you this question, and then I can wait for, depending on the size of the question, I can wait for 2 to 3 minutes or 5 minutes max to max. And then within this limit, if I don't get any response, then I'll move on. If I get response, I'll say, okay, thanks. Thanks for giving me the answer. But not praise. Oh, very good. Wow. Not this kind of things I shall not do. I have stopped doing that. Because I'm not sure about whether you have done it by yourself or have copied it from somewhere. But in the offline class, if I ask you any question and you can give me the answer seeing face to face me with me, okay, then I can praise you. Yeah, okay, fine, very good. Okay. So I'm going to ask you and something, try to solve it out and put the answer in the chat box. And that is the starting point for our today's class. So I'm giving you a game matrix. The game matrix is like this, M, and we have 3, -1, -1, and 9. So that is for player A and that is for player B. These places are for player A and player B. What you need to do is that you are going to give me the max min value and the minimax value. And if possible, you are going to give me the value of the game. Okay, so I'm waiting for your response. So I'm enabling the chat box, and if you can do it, write the answer in the chat box. Maximin is -1, minimax is 3. Okay, maximin is -1, minimax is 3. And what about the value of the game? Does value of the game exist? Okay, why not? Why not? Why not? No, since value of the game doesn't, yeah, okay, yes. Huh? Oh, yes, fine. Since, okay, I have got. Since maximin value here is not equal to minimax value, since maximum value here is not equal to the minimax value, that's why the value of the game does not exist. And if you talk about saddle point, if you talk about saddle point, then it means a saddle point will only exist when the value of the game exists, because the place where the value of the game is present in the matrix is called saddle point. It's called saddle point. Now, can you tell me, uh, value of the game, this value of the game, if exists, will it be a part of the matrix or it will be something outside the matrix? I mean, something which is not part of the matrix, or will it be a part of the matrix? If for certain problem, value of the game exists, will it be a part of the matrix or something else? What is your answer to this question? Obviously part of the matrix. And since it is a part of the matrix, Since it is a part of the matrix, obviously these matrix elements are actually residing in a particular cell, and therefore that cell, these cells, these cell numbers, this cell number is 1 1, this cell number is 1 2, this cell number is 2 1, this cell number is 2 2. If the value of the game exists, then either of these cell numbers 1 1 1 2 2 1 2 2, these cell numbers will be, can be saddle points. Okay, saddle point is the place where value of the game resides. Okay, so if no value of the game, so I'm asking you this question: which of the following statements is true? So my first statement is that you are going to tick to true or false. Okay, statement number one is that since saddle point does not exist, so value of the game does not exist. Question number two is, statement number two is, since value of the game does not exist, so saddle point does not exist. Okay, so what is your, okay, so someone is writing one false, two true. Someone is saying that one is false and two is true. Now why is it so? Why are you saying that number one is false? Yeah, okay, fine. So why are you saying that number one is false? What is the logic? What is the logic that for which you are saying that number one statement is false? I think it would be nice if I allow you to unmute yourself so that you can unmute and answer. But in that case, everybody will try to unmute themselves. So there will be chaos. Okay, so Arithropal has written something. Arithro, if you write your answer to not directly to me, but to everyone, so that everybody will get to see your reply. So try to put it in, try to put your answer. Yeah, okay. So if we did not, he has written that if we didn't get the game point, then saddle point doesn't exist according to the definition. When a criminal, actually, when we are looking for a criminal who has made a crime, so actually the place of the criminal is not first searched. Okay, first of all, we try to identify what sort of criminal we are looking for. Okay, and then we are going to track, we are going to track him by pinpointing those places where he could be. First, we do not pinpoint the criminal, and then I will just don't put the traps. First of all, we say that this might be this may be our suspect, and he can come to that point, he can go to that point, or he can be there or here, and accordingly we put our traps to nab him. So similar is the case with the game value. First of all, by using von Neumann maximin and minimax criteria, we try to identify the value of the game, and if it exists, then we try to locate the saddle point. So therefore, from that perspective, this particular statement is wrong. But if you don't think on this particular issue, these two will look same to you. You may think that, yeah, that is true and that is also true, if you do not think it properly. Now here lies the, this punchline for this today's class, that which I am going to write over here, that in the game above, the value of the game does not, in this matrix, the value of the game does not exist, because the value of the game value of the game does not exist above, but we are not sure whether this won't exist under some special situation. Very confusing line I have written. So what is that? The value of the game doesn't exist. First of all, we try to find the value of the game over here, and it is not existing. But if you want to do mathematics with something, then you have to look in every corner. You have to look at every corner to see whether everything is falling under along the line or not. Now here, this particular matrix, you will see that this matrix is not having the value of the game, but under certain situations, certain scenarios, it will have. And that scenario which I'm going to discuss right now. Okay, so what is that scenario? I shall be discussing that by putting this definition in the next page. So first of all, my definition is like this. Mixed strategy, it is my definition of today's class. I'm writing the definition by copying it from the book which I shared with you by Game Theory by Ian Barron. So I'm writing the definition from there. A mixed strategy is a vector. Mixed strategy is a vector, capital X, x1, x2, dot dot dot, xn, for player 1, and capital Y is equal to y1, y2, dot dot dot, ym, for player 2. I could have presented the page of the book, but if I do so, I shall not be able to discuss whenever it is required, because that would be kind of reading only. This particular definition needs lots of discussion, so therefore I am taking the pain of writing it in the whiteboard. And you also will have to have some kind of patience if you want to learn something new. If you do not have this patience, then mathematics is not for you. Remember, any subject is not for you. And yj greater than or equal to 0, summation yj is equal to 1, j is equal to 1 to m. The components xi represents the probability. So you are now familiar with probability, so you will not be having any trouble to understand this portion. So probability that, and that also gives you how two different topics are related to one another. When often we learn something, and if we are kind of repulsive towards the subject, we say that why should we learn the probability theory, because probability will not be required for me. Now, optimization technique and operation research is required for, I think it is required, it is actually very important topic for each and every student of management. And if he wants to control if the management student wants to control a game, kind of game in a company, corporate game he wants to play with, then if he doesn't have any idea about basic idea of probability theory, then he'll be actually a loser kind of thing. So probability that rho I will be used by player 1 so you can write it as the following: xi is equal to probability, probability I uses rho I, and and yj, and yj, the probability, the probability column j will be used by player 2. That is, yj is equal to probability that 2 uses column j. There is a printing mistake in the book. So in if the book, if the page is in with you, I mean, if you can see the page of the book where mixed strategies are written, you will see that they have written probability 2 uses row j. So that is a printing mistake. That would be column j. Okay. So what is the mixed strategy? Is a vector. First of all, we have to identify what is mixed strategy. In my last class, I talked about pure strategy. I talked about pure strategy. I said that, yeah, if you can recall, every matrix which I discussed in my previous class, every matrix had some kind of heading, column heading and row heading were there. Okay, if you can recall. And I talked about those headings as I told you that those headings are actually the strategies of the player. It's a rock paper scissors. I told that the rock paper scissors are pure strategies. That which I told you about pure strategy, that this rock paper scissors are the pure strategies. That statement is actually not mathematical statement. It is a non-mathematical statement, because if you replace rock paper scissors by something else, index finger, middle finger, ring finger, then again I have to say that, yeah, index finger, middle finger and ring finger, these are pure strategies. So every time I have to specify that, yeah, these are the pure strategies, these are the pure strategies. But my definition has to be universal. Whatever I change over there, that should automatically be implied that what it is. So that definition which I that thing which I told you about, that this is a pure strategy, these strategies are pure strategies, it was not a mathematical definition. Pure strategies are actually coming from mixed strategy. These are actually the special cases of mixed strategies. Okay, so what is mixed strategy? For example, if I consider my today's matrix, what was the matrix? 3 minus 1 and minus 1 9. So I'm writing it over here. If I consider this matrix 3 minus 1 and minus 1 9, what you will see that if this is your player B and that is your player A, and if you ask me, if you consider what will be the probability with which a particular player is selecting his strategy. Suppose you are putting probability that you are saying you are the maximizing player by yourself, and you are saying that I shall consider the strategies, this strategy, this row or that row, whatever the row heading is, with 50% probability. And if player B is deciding that he will be selecting the strategy with probabilities 1/3 and 2/3, okay, then this, if I write like this, half 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 comma half, that becomes a mixed strategy. This is your mixed strategy for player A. And if I write it as 1/3 and 2/3, that will be a mixed strategy for player B. Mixed strategy for player B. So mixed strategies are actually the probabilities. Know the row heading names and column heading names. Mixed strategies are what? They are probabilities. Okay. Now, again, suppose you are saying that, okay, no, someone thinks that, okay, no, that is not the thing. I'm considering this matrix, I'm considering this matrix B, A for A and B, and these are the values which we actually know as payoffs, and you decide that the probability with which player A select row 1 is 1 by 4 and 3 by 4, and player B selects with probability half and half, then in that case, the mixed strategy for player A will be 1 4 3 by 4, and mixed strategy for player B will be half comma half. So whatever you decide about the probabilities with which you are going to select the strategies for player B, and you are not actually going to select the strategies for player B and player A. Player A and player B are going to do this by themselves. So in that case, we shall consider those probabilities as mixed strategies. We are trying to analyzing. We are actually probabilities are what? When the experiment is done but we are not sure about the outcomes, then we try to put some kind of proportions or probabilities to them. So actually, maybe the corporate game is playing over somewhere, or the upcoming assembly election where BJP and Trinamool Congress are fighting among themselves. They are playing somewhere. You are not a part of the game, but you can sit at your home and you can analyze the situation. You will not be getting a 2 by 2 matrix. Then you are going to get a huge matrix. I'm not sure about how many strategies will be there, because it's a political game. So therefore, this particular thing you are actually trying to mathematically analyze. Okay, and that probabilities are actually called the mixed strategies. So similar is the case over here. Half half, 1 4 3 4. In general, they have written, suppose a player is having n number of strategies. So this is the probability for selecting row 1. This is the probability of selecting row 2. This is the probability of selecting row n. And similarly, this is the probability of selecting column 1. This is the probability of selecting column 2. And this is the probability of selecting column m. Here you see that n and m, these are different. N is not equal to m. N can be greater than m. Sometimes n equals to m, and sometimes n is less than m. So there is no restriction. There is no restriction. Okay. If n equals to m, that is all right. Say in our case, n equals to m. We have considered a 2 by 2 matrix. The strategies for player A and player B, both of them are same. Number of strategies for player A and player B are same. But if it is not same, then either number of strategies for player A is greater than number of strategies for player B, or number of strategies for player B is greater than number of strategies for player A. If, okay, and if the number of strategies means probabilities. Number of strategies of one player is greater than number of strategies of other player, in that case the game is called rectangular game. And if number of strategies of one player is same as a number of strategies of other, then in that case the game is called square game. The game is called square game. Okay. So So that is all about mixed strategy. And what is pure strategy then? So you can ask me these questions, or what is pure strategy? So again, I'm considering this matrix. So my matrix is for player B and player A, 3 minus 1 minus 1 9. So you can ask me, if you ask me, sir, what will be the mathematical definition for pure strategies? So I'll say that suppose player A is selecting this row 1 with probability 1 and row 2 with probability 0, and suppose player B is selecting column 1 with probability 0 and column 2 with probability 1. That means player A is certain about selecting this row, and player B is certain about selecting that row, so that sum of the total probabilities is 1 in both the cases. In that case, 1 comma 0 will be called pure strategy for player A, and 0 comma 1 is called the pure strategy for player B. I think you have so these pure strategies are also a kind of probabilities. Okay, certain probability 1 and null probability is 0. And in that, from that perspective, we can say that pure strategies are actually a special type of mixed strategies. Pure strategies are actually a special case of mixed strategies. Okay, so now if someone asks you what are pure strategies and what are mixed strategies, so you always start with mixed strategies and then you'll try to say what pure strategies is. If you start with pure strategies, then to make him understand what mixed strategies are, you will have to give some kind of, I mean, you have to take some kind of trouble to make him understand. If and a person who has no concept of probability, he's not going to understand about either mixed strategy or pure strategy. You quickly write your names in the chat box, and even if you miss, you can do so in the next session. This session is going to end soon, and I'm going to continue in the next session.